So here we have a what looks like a normal everyday integral. Uh, However, if you look at the integrand, it's undefined for x equals 0. As a matter of fact, there's a vertical asymptote at x equals 0. So this is an improper integral because we can't start at a vertical asymptote. So to take care of that, I'm just thinking we have a vertical asymptote here. We're integrating from 0 to 4. I'm not sure what this graph looks like, but let's just say it looks like that. We can't start at 0. So what we're going to do is we're going to start this integral at a. That's our typical letter we use for a lower limit. But we have to figure out, like, a, where are we really starting from? We can't start from 0, but we want to start as close to 0 as we can get. So basically, we're trying to get as close to 0. So a is going to be as close to 0 as we can get coming from the right. So that sounds a lot like a limit, a one-sided limit, and it is. So we're going to take the limit as this lower limit a approaches 0 from the right side of it. So this is how you do this integral. Now we have a lot of work to do as far as integrating and taking the limit, but we can do that. So first of all, let's look at the integral. It's a somewhat complicated integral, but when you notice that if you make u 1 plus the root of x, du is going to be 1 half x to the negative 1 half, which is 1 over 2 root of x dx, which is perfect because dx over x, dx over the root of x, that means equals 2 du. So this integral we're looking at is going to be 2 du times 1 over u, because that root x dx is just 2 du. So it becomes a pretty simple integral. The integral of 1 over u is the natural log of the absolute value of u. So that's our integral. So let's transfer it to all of this. And if this part didn't make sense or you didn't follow it, just break it down. Pause and break it down. You'll get that integral. So this integral becomes a limit as a goes to 0 from the right of, we have 2 times the natural log of, it was u, but make sure you plug your x back in because our limits are still x. So u was 1 plus root of x. And we're going from a to 4. Normally what I do is I factor out my constants when I evaluate. I also factor out constants from the limits. That's just my preference. You do not need to do that. I feel it just cleans it up a little bit. And so now we're going to evaluate this natural log function from 4 to a. So this would be ln of 1 plus root of 4, which is 1 plus 2, 3, minus the natural log of 1 plus the root of a. Now I don't need the absolute value signs because I know I'm in the positives. 1 plus the root of x is always going to be positive. Oops, this was from an old question. So now we evaluate the limit. The limit as a goes to 0 of natural log of 3, that's constant, is natural log of 3. The limit as a goes to 0 of this, well, when a goes to 0, that would be 1 plus 0, which is 1. This would be the natural log of 1, which is just 0. So we have our answer. This converges to 2 natural log of 3. That's it.